Hello to all, I am Gurmeet Singh. Welcome to CREATA Classes and also welcome to our lecture on one short video of Chapter 6, Class 10, Triangles. Note that this lecture is a one short video, so it will be slightly fast as compared to our other theory video. If you want to go slow or you have enough time to cover the lecture in a slow pace, check out the complete playlist in the description. We have a complete playlist for the chapter Triangles. It will be slow and in more detail. Okay, this is a one shot video, so it will be slightly fast. This lecture we have prepared using the animation and the visual tool. Also check the description for the complete PDF of the formula and the concept list. So without taking any further time, let's start with the lecture. This lecture is all about the similarities of the triangle, which is somewhat matching with the congruency of the triangle that you have done in the previous class 9. Congruency and similarities are somewhat same concept, so you should know the difference between them. In the congruency, the two figures are having the same shape and same size. We can say two figures are congruent if they are exactly copy-paste of each other. Their size are also same and their shape are also same. While in the similarities, two figures are similar if they are having the same shape. Two figures having the same shape, we can say they are similar to each other. Here, size does not matter. Size can be smaller, size can be larger, or size can be same. The only thing that matter in the similarity is the same shape. So congruency is having two components, same shape and same size, while similarity is having only one component, that is same shape. So we can say all the congruent figures are also the similar figures. But the opposite is not true, that is all the similar figures are not the congruent figures. Got it? Congruency is having one additional component as the size, and similar figure can have the same size or cannot have the same size. It does not matter. Only thing matter is they are having the same shape. Same shape means we can increase the size or decrease the size of one of the figure and exactly match with the other figure. Then we can say both are having the same shape, that is they are similar to each other. Here these two figures are similar to each other. We can take the right hand side figure, we can decrease the size or increase the size, and both will exactly match with each other. Moving further, there are some geometrical figures which are always similar to each other. For example, if we take the circle, you can take any circle, larger circle, smaller circle, any radius of the circle. Here all these circles will be similar to each other. You can increase or decrease the size of all these circles, they will exactly match with each other. The other geometrical figure in the same criteria is the square. You can take any number of square, big, small, any square, just decrease or increase the size, they will match each other. Means all the squares are having the same shape. The third and the last example in this category is equilateral triangle. You can take any equilateral triangle, any dimension. If you increase or decrease the size, they will match with each other, or we can say they are having the same shape. So we are having three examples which are generally asked in the examination: circle, square, and equilateral triangle. These geometrical figures are always similar to each other in their own category. Got it? Moving further, if we talk about the similarities of the polygon, how we can check any of the two polygons are similar or any of the two figures are similar or not. In case of polygon, we are having two conditions. If the two conditions are matching, then we can say the given polygons are similar to each other. The first condition is that the corresponding angles should match with each other. Here in this two figure, these are the corresponding angle. If all these corresponding angle, the respective corresponding angles are equal to each other, we can say our first condition is matching. That is, the corresponding angles of both the figures should match with each other. The second condition is regarding the corresponding sides. The first is regarding the angles, second is regarding the sides. The second condition is that the ratio, note that the word ratio, the ratio of the corresponding sides should also match with each other. Here we will take the corresponding sides, these are the corresponding side. We have to take the ratio, we do not have to equate the corresponding side. We have to take the ratios of all the corresponding side, and the ratios of all the corresponding sides will be equal. If the ratio of the corresponding sides are equal, then we can say our second condition is also matching.
If both the conditions are matching, then we can say the two polygons are similar to each other. If only one condition is matching, second is not matching, then we can conclude the figures are not similar to each other. Matching of both the condition is must to check both the figures are similar or not. Note that this is for any polygon. You can take pentagon, hexagon, triangle, square, any polygon. These two conditions, these concepts will remain the same. And in this chapter, we are doing the concept with respect to triangle. So triangles are also a type of polygons. Like the basic form of polygon is a triangle. So in the triangle also these conditions are matching, that is the corresponding angles should match with each other and the ratio of the corresponding sides should also match with each other to prove or show both the triangles are similar to each other. But triangles are having a certain additional property that we do not have to every time check both the condition. We are having three criteria specially for the triangles. Let's see. The first criteria is angle, 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 that is AAA criteria. As per AAA criteria, if only the corresponding angles of two triangles are matching with each other, then the two triangles are similar to each other. We do not have to go for the second condition, that is corresponding sides. The ratio of the corresponding sides will automatically be equal if the corresponding angles are matching with each other. So as per angle criteria, if we are having two triangles and the respective corresponding angles are matching with each other, then we do not have to check for the ratio of the corresponding side. The second condition, the two triangles will automatically be similar to each other. So this is the first criteria. Second is side, side, side. That is SSS criteria. As per this criteria, if two triangles, the ratio of the corresponding sides are matching, then the two triangles are similar to each other. We do not have to check for the corresponding angles. The corresponding angles will automatically be equal. So in the second condition only we will check the ratio of the corresponding side. Note that here we are not matching the corresponding side. We are matching the ratios of the corresponding side. This is important. This is different from the congruency. So here ratios is very important. Do not forget this in the mid of the examination. This is important. The third is side, angle, side, that is SAS criteria. As per this criteria, if in the two triangles the ratio of the two corresponding sides, two set of corresponding sides are equal and the angle in between the two given corresponding sides are also equal. Here in this case, these two set of corresponding sides, the ratio is equal and the angle in between the two corresponding sides is also equal. Then we can say the two triangles are similar to each other by SAS criteria. So these are the three criteria or the three similarities rule through which we can check the two triangles are similar or not. So we have understood the concept of similarities of the triangle. Let's also understand how to write two triangles as similar to each other. This is very important and students generally do mistake in this part. Suppose we are having two triangles ABC and DEF. Here angle A and angle D are the corresponding angles which are equal to each other. B and E are the corresponding angle and C and F are the corresponding angle. We will write the two triangles as similar to each other as triangle ABC is similar to triangle DEF. This is the symbol of the similarity. Here both the triangles are similar. The point to be noted here is that the corresponding angle should be in the same order. Here A and D are the corresponding angle, so they should match each other. B and E are the corresponding angle, so they are matching, and C and F are the corresponding angle, so these two angles are matching. The order is very important. ABC should match with the order DEF. If you are having two triangles and you have to write the two triangles as similar to each other, just rotate the triangle, flip the triangle, do whatever it is required to make the corresponding angle side by side. Here A should match with D, B should match with E, and C should match with F. Then only you will be able to write the sequence of the vertices of the triangle in order. So this is one of the important concepts that students generally miss out.
Let's further go deep to the concept by going through some of the questions. After these questions, we will do the concept of BPT. If you want to skip the questions and directly want to cover the BPT theory, just go to this timeline. For the time being, let's cover some questions related to the theory we have covered till now. Okay, let's start with the first question. Question number 1. State which pair of triangles in figure 6.3 are similar. Write the similarity criteria used by you for answering the question and also write the pairs of similar triangle in the symbolic form. So various figures are given. We have to check whether the two figures in each part are similar or not. Let's take the first part in which we are given the triangle ABC and triangle PQR. Here on observing, the three angles of both the triangles are given. Angle A and angle P are given as 60 degree, that is both are equal to each other. Angle B and angle Q are given as 80 degree, both are matching. Similarly, angle C and angle R are both given as 40 degree. The three corresponding angles are exactly matching with each other. So we can say both the triangles are similar to each other based on angle criteria, that is AAA criteria. So we can write the triangle ABC is similar to triangle PQR. Here angle A and angle P are matching, angle B and angle Q are matching, and angle C and angle R are matching. So that is for the part 1. Let's move to part 2. Here we are again given the triangle ABC and PQR. This time we are given the three sides of the triangle. Here AB is 2, AC is 3 and 2.5 is the BC. Similarly 6, 5 and 4. If you directly observe the two triangles, here the concept of the ratio of the corresponding sides will be applicable. Why? Because angles are not given. If we have to check the two triangles are similar or not, we will check the ratio of the corresponding sides are equal or not. Here if we take AB and PQ, that will be 2 by 6, that is 1 by 3. If we take AC by PR, it will be 3 by 5. And if we take BC by QR, it will be 2.5 upon 4. So basically by looking, we can say both the triangles are not similar to each other. But this question is having a trick. The trick is that the right hand side triangle, that is the triangle PQR, is shown in the rotated form. If we rotate this triangle, now the side 2 is matching with side 4, side 3 is matching with side 6, and side 2.5 is matching with side 5. Basically 2 by 4 is 1 by 2, 3 by 6 is 1 by 2, and 2.5 upon 5 is 1 by 2. Now we can say the corresponding sides are matching. Basically in the first time we have not taken the right corresponding sides. We have taken the wrong one. Here AB will correspond to QR and AC will correspond to QP and BC will correspond to PR. And these are the corresponding side and the ratio of these corresponding sides are equal to 1 by 2, basically equal to each other. So we can say here both the triangles are similar to each other by SSS criteria, that is side criteria. But the trick is how we will write this triangle as similar. We will write triangle ABC is similar to triangle QRP. Here A should match with Q, B should match with R, and C should match with P. So the sequence of the vertex of the triangle matters in similarity. So this is a perfect example of that. Okay. We cannot write triangle ABC is similar to triangle PQR. Here we have to write ABC is similar to QRP. The sequence matters. Let's move to part 3. Here again we are given two triangles and the sides of the triangles are given. Let's see whether the ratio of the corresponding sides are equal or not. If we observe 2.7 upon 4, if we take these two corresponding sides, it is 2.7 upon 4. If we take these two corresponding sides, it will be 3 by 6, which is basically 1 by 2. And if we take these two corresponding sides, it will be 2 by 5. So we can say the corresponding ratios are not matching in this triangle. You can rotate the triangle, you can flip the triangle, you can do anything. Still, the ratio of the corresponding sides will not match with each other. So these two triangles are not similar to each other. Got it? These two triangles are not similar to each other because by rotating, by flipping, by doing anything, the ratios of the corresponding sides are not matching with each other. Got it? Let's move to the fourth part. Here triangle NML and QPR are given. Let's check whether they are similar. One angle is given and two sides are given. Okay. Here angle M and angle Q are matching, that is 70 degree. Let's rotate the right hand side triangle to match this 70 degree with 70 degree. Here M and Q are matching, so the corresponding angles are matching. So we can rotate this triangle for better clarity and better visualization. In the exam also you can draw a small triangle on the right side of the figure, the rotated one. It became easy to exactly match both the figures. So we have rotated the triangle, 70 is matching with 70. Here MN will correspond to QR and ML will correspond to QS. By doing so, let's check the ratio of the corresponding side. It will be 2.5 upon 10, that will be 1 by 4, and MN upon QP will be 5 upon 5, that is 1. So here both the triangles are not similar to each other as their ratio of the corresponding side are not matching. But wait, hold, one more trick is here. Here the ratio of the corresponding sides are not matching. But if we just flip the triangle with the axis around the angle Q, here we got the corresponding side to MN as QP. Got it? Now if we take the ratio of MN upon QP, it will be 2.5 upon 5, that is 1 by 2. And if we take the ratio of ML upon QR, it will be 5 upon 10, that is 1 by 2. Now the ratio of the corresponding sides are matching. Are you able to analyze this figure? Here we have rotated the triangle and also flipped the triangle around the Q axis, that is axis around the Q angle. So you have to rotate the triangle, also flip the triangle to match the corresponding sides. Then only you can be sure that the ratio of the corresponding sides are matching or not. Now if you observe two set of corresponding sides ratio are matching, and angle in between the two corresponding sides are also matching. So by SAS criteria, side angle side criteria, both the triangles are similar to each other. Got it? So how we will write both the triangles are similar? We will use the corresponding angles. So triangle NML will be similar to triangle PQR. So a tricky question but very important question. So every time you have to rotate and flip the triangle. Or you can apply the small trick. You can just observe the sides of both the triangle and you can check whether any ratio is coming. Like here 5 is basically double of 2.5. And on observing 5 and 10, you can observe that 10 is double of 5. So 2.5 and 5 ratio is 1:2, and 5 and 10 the ratio is again 1:2. So in this way you can observe whether the two sides are in the same ratio or not. And by doing so you can rotate or flip the triangle accordingly to match the corresponding sides. Okay. Let's move to part number 5. Here triangle ABC and triangle DEF are given. One angle is given 80 degree, angle A, and angle F as also 80 degree. Two sides are given, and in the second figure also two sides are given. Here 2.5 and 5 are basically 1:2, and 3 and 6 are again 1:2. So something it is matching. Let's flip the triangle to match the ratio of the corresponding side as equal. That is AB should match with DF because the ratio is 2.5 upon 5, that is 1:2 or 1 by 2, and BC with EF 3 by 6, it is 1 by 2. On flipping the triangle we got one set of corresponding side as equal, but we are not able to get the angle between the two corresponding sides. Here these angles are missing. Some additional angle are given which are given as equal. In that case one of the side is missing. Basically we are not having the complete data to check whether the two triangles are similar or not. So we can say these two triangles are not similar to each other because none of the criteria AAA, SSS or SAS are matching. Got it? So let's move to the last part, part 6. Here we are given the triangle DEF and the triangle PQR. Here two angles of the triangle are given. One angle is missing in both the triangle. In the triangle DEF 70 and 80 degree are given, and in the triangle PQR 30 degree and 80 degree are given. Angle E and angle Q are matching equal to 80 degree, but angle D and angle R are not matching. Let's find the third missing angle using the sum property of the triangle. That is, the sum of three sides of a triangle is 180 degree. So in the triangle DEF, angle F will comes out to be 180 degree minus 80 minus 70.
So angle F is 30 degree. Similarly, let's find the angle P. That will be 180 minus 80 minus 30. That will comes out to be 70 degree. So we got all the three angles in both the triangle. Now on observing, we can see the set of the three corresponding angles are matching. Here 70 degree are matching, 80 degree are matching, and 30 degree are matching. So we got both the triangles are similar using the A criteria, that is angle criteria. So let's write it down. Triangle DEF is similar to triangle PQR. Got it? D is matching with P, E is matching with Q, and F is matching with R. So we got this triangle as similar to each other. We have done with this question. Let's move to the next question. In the figure 6.36, QR upon QS is equal to QT upon PR and angle 1 is equal to angle 2. Show that triangle PQS is similar to triangle TQR. So let's observe the question. Here in this question, one big triangle is given QTR and which is having several triangles inside this big triangle. Here it is given QR upon QS is equal to QT upon PR. Further, it is given angle 1 is equal to angle 2. And we have to prove or show that triangle PQS is similar to triangle TQR. So let's see how we can approach this question. Firstly, let's identify the triangle which we have to prove as similar to each other. This is a triangle PQS and this is a triangle TQR. So how we can prove the two triangles as similar to each other? Either we can prove the angles, the three angles are equal, or we can prove the ratio of the corresponding sides are equal. Or we can use the SAS similarity rule, that is the set of two corresponding sides, the ratio is equal and the angle in between them is equal. Let's see what we can use here. Here in both of this triangle, angle 1 is common. If we somehow able to prove the ratio of these corresponding sides as equal, then we can say both the triangles are similar as per SAS criteria. These two corresponding sides and the angle in between them, SAS criteria. Note that we are just discussing the strategy. If we are able to prove the ratio of the corresponding side of both of this triangle as equal to each other, then we can say by SAS criteria both the triangles are similar to each other. So let's take the corresponding side. Here QR is corresponding to QS and QT will correspond to QP. So the corresponding ratio that will form is QR upon QS is equal to QT upon QP. Somehow we have to get this equation. Let's see how we can get this equation. Once we get this equation, by SAS rule we can simply say both the triangles are similar to each other. Let's see. Here in the question it is given QR upon QS is equal to QT upon PR. If we compare both of this, here the three terms are matching. Here only the term PR and QP are not matching with each other. If somehow we are able to show or prove PR and QP are equal to each other, then we can easily solve this question. Firstly, let's identify what is PR and what is QP. This is PR and this is QP. Here, if you observe the figure, these two are the sides of the triangle PQR. So this is a triangle PQR in which angle 1 and angle 2 are given as equal to each other. We know the property of the triangle. The side opposite to equal angles are equal to each other. So angle 1 and angle 2 are equal. The side opposite to these two angles will be equal to each other. So we can say QP and PR will be equal to each other. So we got QP and PR, both of these terms as equal to each other. Let's replace PR with QP. So we got QR upon QS is equal to QT upon QP. These are the ratio of the two corresponding sides of these two triangles. So the ratio of the two corresponding sides are equal and the angle between the two corresponding sides are equal. So we can say the triangle PQS is similar to triangle TQR using the SAS similarity rule. Side, angle, side. These are the two corresponding sides and this is the angle in between the two corresponding sides. Got it? We have applied the SAS similarity rule and we have proved the triangle PQR is similar to triangle TQR. I could have easily started with the solution, but I have used slightly the long approach to tell you how to approach the question, what you should think in the exam to solve the question. I could have started by taking angle 1 is equal to angle 2, so the opposite side will be equal. But I have not gone directly to the formulas. I have used the approach how to solve the question. We have done with this question. Let's move to the next question. E is a point on the side AD produced of a parallelogram ABCD and BE intersects CD at F. Show that triangle ABE is similar to triangle CFB. The wording of the question is very important, so pay your attention on the wording. Let's observe the question. In this question, a parallelogram ABCD is given. So let's draw the parallelogram ABCD. Further, it is given we are having a point E on the side AD produced. AD produced means we have to extend the side AD, which will have the point E. Further, it is given BE intersects CD. BE means we have to draw the line segment BE. Let's join B and E. And BE is intersecting CD. Yes, it is intersecting the line segment CD or the side CD at the point F. So this will be the point F. So this is given in the figure. We are having a parallelogram ABCD and AD is extending up to the point E, and we are joining B and E to form the line segment BE, which is intersecting the side CD at point F. Further, we have to prove or show the triangle ABE is similar to triangle CFB. Firstly, let's identify the two triangles. So these are the two triangles which we have to prove as similar to each other. One important tip that can be helpful to solve such type of question: pay attention to the notation or the order of the three vertex of the triangle. Here we have to show the triangle ABE to be similar to triangle CFB. A is matching with C and B is matching with F and E is matching with B. Basically, these are the corresponding angles which should match with each other to prove or show the triangles as similar to each other. So let's rotate one of the triangle to fit this notation or this order. So these are the two triangles. Now the corresponding angles are side by side. Can we say here angle A, this angle is equal to this angle, or this angle is equal to this angle, or this angle is equal to this angle? If we are able to prove any of the two angles as equal, then by angle criteria, we can say both the triangles are similar to each other. Let's do so. Here angle A and angle C, these two angles in the main figure are equal to each other. Why? That is the property of the parallelogram. The opposite angles in the parallelogram are equal. So angle A is equal to angle C. One set of angle we got as equal. Let's identify the second angle. Here can we say this angle B and this angle F are equal to each other? Let's check it out in the main figure. Here these two angles are the alternate angles. In the parallelogram, the opposite sides are parallel, means AB and DC will be parallel to each other. And if we apply the concept of the transversal, BE is a transversal, AB and CD are parallel to each other. So these two angles will be the alternate angles, which will be equal to each other in the case of parallel line and the transversal. So we got angle ABE is equal to angle BFC. Two angles we got as equal. So by angle similarity criteria, we can say both the triangles are similar to each other. So the understanding from this question is that we can check out the two triangles which we have to show as similar to each other, and we can match the vertices given in the question itself. Like the A should match with C and B should match with F and E should match with B. So by observing the question itself, we can solve the question. Got it? These small tips will be really helpful in the mid of the exam to solve any of the tough questions. Okay? We have done with this question. Let's move to the next question. In figure 6.40, E is a point on side CB produced of an isosceles triangle ABC with AB equal to AC. If AD is perpendicular to BC and EF is perpendicular to AC, prove that triangle ABD is similar to triangle ECF. So this is the question. Firstly, let's observe the question and also the given figure. In the given figure, we are having a triangle ABC and the side BC is produced up to the point E. and EF is perpendicular to side AC. It means the angle F is 90 degree, and AD is perpendicular to the side BC. It means the angle D is 90 degree. Further, the triangle ABC is given as an isosceles triangle. Isosceles triangle in which the two sides of the triangle are equal. Here AB and AC of this triangle is equal to each other. And we have to prove the triangle ABD, this triangle, and the triangle ECF, this triangle, as similar to each other. We will take down this question by going in the reverse order. We are doing so that you understand the approach that you have to use in the examination. The question will not be direct, the same question will not repeat in the exam, the question may be slightly tricky. So you should know how to approach the question. Do not directly jump to the formulas. Try to observe the question and try to link what is given in the question with the figure and how to approach, what you should think in your mind while seeing this question. Here triangle ABD we have to prove as similar to ECF. You should observe the sequence of this order of the vertices of the triangle, like A is matching with E, B is matching with C, and D is matching with F. And we have to rotate one of the triangle so that the corresponding angles, these corresponding angles order should match. So here we will rotate this triangle so that A should match with E, and B should match with C, and D should match with F. We are doing so that we can visually better approach this question. If you are more creative, you can solve without rotating the triangle, that is very best. But while rotating the triangle, flipping the triangle, just make sure the corresponding angles are side by side. Now we can better analyze the question and match the respective sides and the angles. So here we have to prove both the triangles are similar. That we can do by proving any of the two angles of both the triangles as equal to each other. Then we can apply angle-angle criteria. Then we can show the triangles are similar to each other. Here angle D and angle F are both 90 degree. That is, they are perpendicular to the respective side. So both the angles are 90 and equal to each other. So we got both the angles are equal to each other. Further, can you take down any of the other angle and show both the angles as equal to each other? The hint is given in the question, that is AB is equal to AC. The triangle ABC is an isosceles triangle. AB is equal to AC, so the angle B and angle C will be equal to each other. That is the property of a triangle. The angle opposite to equal sides are equal to each other. AB equal to AC, so the opposite angles will be angle B and angle C. So here we got angle B and angle C are equal to each other. So we got two angles of this triangle as equal. So we got that triangle ABD is similar to triangle ECF by angle-angle criteria. That is the answer of this question. Got it? We have done with this question. Let's move to the next question. The question is, the side AB and BC and median AD of a triangle ABC are respectively proportional to side PQ and QR and median PM of triangle PQR. Show that triangle ABC is similar to triangle PQR. Our first step, we will observe the question and also we will observe the given figure. Here two triangles are given, triangle ABC and triangle PQR, and both the triangles are having the median AD and PM respectively. What is median? Median is a line segment that starts from the vertex of a triangle and joins the midpoint of the opposite side. Here the first median is starting from the vertex A and it is joining the point D, which is the midpoint of the side BC. D is the midpoint, it means it is dividing the BC into two equal parts. Here BD and DC will be equal to each other. Got it? Similarly, in the triangle PQR, we are having the median PM, so M is the midpoint of side QR. M is dividing the side QR into two equal parts. So we got QM is equal to MR. Okay. Further, it is also given the side AB, BC and median AD are proportional to side PQ, QR and the median PM. That is, AB upon PQ is equal to BC upon QR is equal to AD upon PM. This is given in the question. The ratios are given as equal. Further, we have to prove both of this triangle, that is triangle ABC and triangle PQR, as similar to each other. So let's see how we will approach. In the given part, it is given that AB upon PQ is equal to BC upon QR, the first two parts of the given equation. It means the ratio of the corresponding sides. Basically, the two corresponding sides of the main triangle are given as equal to each other. Either we can prove the third side, the ratio of the third corresponding side as also equal to prove both the triangle as similar, or we can prove the in-between angle to both of these corresponding sides as equal. That is, if we prove angle B and angle Q as equal, then by SAS criteria, we can say both the triangles are similar to each other. So we will go through this approach, that is, we will try to prove angle B and angle Q are equal. Let's see how we get there. In the given equation, BC and QR are given. Here we know point D is the midpoint of side BC. So can we replace the term BC, that is side of the triangle BC, with twice of BD? D is the midpoint of BC, so BC will be twice of any one of the line segment. That can be BD. So BC will be twice of BD. Similarly, M is the midpoint of QR, so we can rewrite QR as twice of QM. That is twice of any one of the line segment, one part of the side QR. Here 2 and 2 will cancel out. We got AB upon PQ is equal to BD upon QM is equal to AD upon PM. We got ratio of the three corresponding sides of these two triangles as equal to each other. All these three ratios are the corresponding sides, the ratio of the corresponding sides of these two triangles. Got it? So we can say both the triangles are similar to each other as the ratio of the corresponding sides are perfectly matching by SSS criteria, that is side criteria. Once we got any two triangles as similar, we can say their corresponding angles will be equal to each other. That is angle B and angle Q, angle D and angle M, and angle A and angle P. These three angles will be equal to each other. Why? Because both of these triangles are similar to each other. Let's take only angle B and angle Q as equal. So if you observe in the main triangle, that is triangle ABC and triangle PQR, here we got angle B and angle Q as equal, the same thing just we have proved as equal. And further, it is also given AB upon PQ is equal to BC upon QR. The same thing in the given portion. The ratio of the two corresponding sides are equal and the angle in between these two corresponding sides are also equal. So by SAS criteria, the triangle ABC is similar to triangle PQR. That is the proof of this question. We have done with this question. Let's move to the next question. This question is slightly tricky, so pay your full attention please. D is a point on the side BC of a triangle ABC such that angle ADC is equal to angle BAC. Show that CA square is equal to CB into CD. So this is the question. The question is slightly tricky. Let's understand the question. In this question, we are given a triangle ABC. And also we are having a point D on the side BC. Let's join A and D. So here we are having a big triangle ABC and also two small triangle ABD and ACD. Further, it is also given the angle D, the angle ADC is equal to angle BAC. So these two angles are given as equal to each other. Here angle ADC is given, means this triangle will be applicable in this question, maybe. And further angle A, this big angle is given, it means this big triangle ABC can be applicable in this question. Let's see whether these two triangles are applicable or not. You should try to understand this. Whatever is given in the question, you should try to link that with the figure. The given item will be used to solve the answers. So pay special attention to the item given in the question. Here angle D is given, it means that triangle ADC will be applicable. Angle A is given, it means that triangle ABC will be applicable. And we have to show that CA square is equal to CB into CD. In the theory part, we have not done any of the square formula. We have done only the ratios. So can we rewrite this equation as CA upon CD is equal to CB upon CA? We have just converted the square term that we have to prove as equal into the ratio form, in which we are more comfortable in this chapter. Let's observe what are these four line segments. CA is this line segment, so it can be the part of the big triangle ABC, or it can be the part of the triangle ADC. Further, CD is given. Yes, this is CD, so this is part of the triangle ADC. And further, CB is given, so which is the part of the triangle ABC, the big triangle. And CA again can be the part of the big triangle and the small triangle. So on observing the ratio which we have to prove as equal, we again are getting two triangles, the triangle ABC, the big triangle, and the small triangle ADC. So let's try to observe this triangle and try to prove these two triangles as similar to each other. Once we are able to prove these two triangles as similar, so we can say the ratio of the corresponding sides are equal and we can prove our end result. So let's proceed. Here angle A and angle D in both the triangles are given as equal to each other. So we got one set of angle as equal. And further, the angle C is common in both the triangle. So we got angle C is equal to angle C, that is a common angle. In the two triangle, we got the two angles as equal to each other. So we got the two triangles as similar by angle-angle similarity criteria. And we know the ratio of the corresponding side in two similar triangles are equal. So we got CA upon CD is equal to CB upon CA, which is basically equal to CA square is equal to CB into CD. That is the answer of the question. So are you able to understand how we have approached this question? What you should think in the examination? You should try to link whatever is given in the question with the given figure or the figure that you have prepared. The given item will be useful in solving the question. In the figure, you can also correlate the respective corresponding angle by rotating the triangle. Here angle C is common in both the triangle, so angle C in both the triangle will be the corresponding angle. Angle A and angle D are given, so that will be the corresponding angle. So you can rotate this triangle to match the corresponding angles as side by side to each other if you are not able to identify the respective corresponding sides. In the end, we have shown that the respective corresponding side, the ratio are equal. So you have to identify which are the corresponding side. You can rotate the triangle, you can match the equal angle, and you can say which are the corresponding sides. We have done with this question. Let's move to the next question. Side AB and AC and median AD of a triangle ABC are respectively proportional to side PQ and PR, and median PM of another triangle PQR. Show that triangle ABC is similar to triangle PQR. Let's take down this question. This question is somewhat similar to the question number 12, but the approach and the answer is totally different. Let's see how we approach this question. Firstly, let's understand this question. In this question, we are given two triangles, triangle ABC and triangle PQR, and also the median AD and PM are also given. And we know what is median. Medians are the line segment that start from the vertex of a triangle and joins the midpoint of the opposite side. It means point D and M are the midpoint of side BC and QR respectively. Why? Because AD and PM are the medians for the triangle ABC and the triangle PQR respectively. So we got D is the midpoint of BC and M is the midpoint of QR. Further, it is also given AB and AC and median AD of a triangle ABC are respectively proportional to side PQ and PR and median PM of the triangle PQR. It basically means AB upon PQ is equal to AC upon PR is equal to AD upon PM. These ratios are given as equal to each other. So this is the given part, and we have to show that triangle ABC is similar to triangle PQR. So let's proceed with this question. Here we have to show both of these triangles are similar to each other. If you observe the given portion, here AB upon PQ is equal to AC upon PR. Means the ratio of two corresponding sides of the two triangles are already given as equal to each other. Further, if somehow we are able to prove angle A is equal to angle P, then by side angle side similarity criteria, we can prove or show that both the triangles are similar to each other. So all the effort that we will do in this question will be to prove angle A is equal to angle P. The question is slightly tricky, so your full attention is needed here. Let's proceed. Let's draw the line segment DE which is parallel to the side AC. We have just simply drawn a construction, the line segment DE which start from the midpoint of the side BC, that is from the point D, and it join the side AB at the point E. And this DE is parallel to AC. Both of these line segments are parallel to each other. Similarly, in the triangle PQR, let's draw the line segment MS which is parallel to PR. So both of these line segments are parallel in both the triangle. Here we know the point D is the midpoint and point M is the midpoint. But we do not know whether the point E and point S are the midpoint or not. Here we will apply the midpoint theorem. The same theorem you must have done in the previous class, the class 9th. Through the midpoint theorem, we can say AC and ED are parallel, so the point E will be the midpoint of the side AB. The converse of the midpoint theorem we have applied. Similarly, here we can say PR and MS are parallel to each other and point M is the midpoint of side QR. So point S must be the midpoint of side PQ. Got it? The simple midpoint theorem we have applied. You must have done in the previous class. If we are having a triangle ABC and D and E are the midpoint of side AB and AC, then the line segment DE will be parallel to BC. If we join the midpoint of the two sides, then the line segment formed will be parallel to the third side. And here we have applied the converse. That is, here we know by the construction that is these two line segments are parallel to each other and one point is midpoint, then the second point will also be the midpoint. Midpoint theorem also say that if D and E are the midpoint and DE is parallel to BC, then DE will be half of BC. That is, DE is equal to half of BC. This is also the part of the midpoint theorem. The same concept we will apply in our two triangle. That is, here DE and AC are parallel to each other and D and E are the midpoint of their respective side. So we can say DE will be equal to half of AC. Got it? Similarly, we can say MS is also equal to half of PR. M and S are the midpoint of their respective side and MS is parallel to PR. So we can say MS is equal to half of PR. Further, let's take the given part. This is the given equation in the question. Here let's replace AC with twice of DE and let's replace PR with twice of MS. Further, we know E is the midpoint of AB, so we can replace AB with twice of AE. Got it? E is the midpoint of AB, so AB will be twice of AE. Similarly, S is the midpoint of PQ, so PQ will be twice of PS. Here 2 and 2 will cancel out and this 2 and 2 will also cancel out. We got this equation. And all these 6 line segment or the 3 ratios are the ratios of the corresponding sides of these two triangles. So we can say the ratio of the corresponding sides of two triangles are equal. It means that both the triangles will be similar to each other. So we got both of these triangles as similar to each other by SSS criteria, side, side, side criteria. And we know once the two triangles are similar, all their corresponding angles will be equal. So these two angles will be equal to each other. Let's give the name to this 4 angle as 1, 2, 3 and 4 for simplicity. So here angle 1 will be equal to angle 3. So this is the one important output that we got. Angle 1 and angle 3 are equal to each other. Similarly, by the same procedure, we can also prove angle 2 is equal to angle 4. We are not going into the detail, just angle 2 will be equal to angle 4. So we got angle 1 is equal to angle 3, angle 2 is equal to angle 4. Let's add the left hand side and right hand side. We got angle A is equal to angle B. The same thing that we are looking for, we got angle A and angle B as equal to each other. Once we got these two angles as equal to each other, we can apply the side angle side criteria in both of these triangles. Let's see. Here if we take the triangle ABC and triangle PQR, AB upon PQ is equal to AC upon PR, that is given in this question. So the ratio of two corresponding sides as equal in both the triangle, and further in between angle to these two corresponding sides, that is angle A and angle P are also equal. The same thing we have proved as equal. So by side angle side criteria, we got both the triangles as similar to each other. That is the answer of this question. We have done with this question. Let's move to the next question. A vertical pole of length 6 meter casts a shadow 4 meter long on the ground, and at the same time a tower casts a shadow 28 meter long. Find the height of the tower. So a practical life question, very interesting question. Let's approach the question. A vertical pole of length 6 meter is given, which is casting a shadow, and the length of the shadow is 4 meter long. The height of the pole is 6 meter and the length of the shadow is 4 meter. And at the same time a tower is also given, whose total height we don't know, that we have to calculate, and that tower is also casting a shadow. The length of the shadow is 28 meter long. So we are having a pole and a tower, both are casting the shadow. So in this question we have to find the height of this tower. Let's denote the height of the pole as AB and height of the tower that we have to calculate as PQ. The length of the shadow in the case of pole be BC, which is 4 cm, and the length of the shadow in case of tower be QR, which is 28 meter long. Let's join A and C, it will form the triangle ABC. And let's join P and R, we got the triangle PQR. Basically we have converted the practical scenario into the two triangles. Here we are having the two triangle ABC and triangle PQR. Here the angle B and angle Q will be 90 degree. The pole and the tower are perpendicular to the ground, so these two angles are 90 degree. Here angle C and angle R will also be equal to each other. The shadow in both the case are casting at the same time as given in the question, so this angle will be equal in both the cases. So we got two angles of the triangle as equal, the corresponding angles are equal, so we can say both the triangles are similar to each other based on angle criteria. Once we got the two triangles as similar, we can say the ratio of the corresponding sides will be equal. That is BC upon QR will be equal to AB upon PQ. We know the three values. Let's find the value of PQ. That is the height of the tower, which is 42 meter. So we got the answer. The height of the tower is 42 meter. That is the answer of question number 15. We have done with this question. Let's move to the next question. If AD and PM are medians of triangle ABC and PQR respectively, where triangle ABC is similar to triangle PQR, prove that AB upon PQ is equal to AD upon PM. So this is the last question. Let's observe the question. In this question, the triangle ABC and triangle PQR, two triangles are given, and we are having the median AD and PM. We know medians join the opposite side at the midpoint. So the point D is the midpoint of side BC and point M is the midpoint of side QR. Further in the question, it is given triangle ABC is similar to triangle PQR, and we have to show that AB upon PQ is equal to AD upon PM. Here AB and PQ are these two sides and AD and PM are these two sides. Basically these are the corresponding sides of triangle ABD and PQM. If somehow we are able to prove these two triangles as similar to each other, then we can say the ratio of the corresponding side will be equal and we can prove our final result. So here we will try to prove both of these triangles as similar to each other. So let's proceed. Here in the question it is given the triangle ABC and triangle PQR are similar to each other. Two triangles are similar means the ratio of their corresponding sides will be equal to each other. So we can say for these two triangles AB upon PQ will be equal to BC upon QR. We have taken only the two corresponding sides. Here we know point D is the midpoint of side BC. So can we replace the term BC, that is side of the triangle BC, with twice of BD? D is the midpoint of BC, so BC will be twice of any one of the line segment. That can be BD. So BC will be twice of BD. Similarly, M is the midpoint of QR, so we can rewrite QR as twice of QM. That is twice of any one of the line segment, one part of the side QR. Here 2 and 2 will cancel out. We got our equation as AB upon BQ is equal to BD upon QM. Further, let's take the triangle ABD and triangle PQM and let's try to prove both the triangles as similar to each other. Just now we have seen AB upon PQ is equal to BD upon QM. That is, the ratio of two corresponding sides are equal to each other. And also the angle in between these two corresponding sides, that is angle B and angle Q, are also equal to each other, because these two angles are the corresponding angles of the triangle ABC and triangle PQR, which are already given as similar to each other. So the two big triangles are similar, means the corresponding angles will be equal. That is, angle B will be equal to angle Q. So these two triangles are similar to each other by side angle side criteria. Further, once the two triangles are similar, we can say the ratio of the corresponding sides will be equal. So we got AB upon PQ, which are the corresponding sides, is equal to AD upon PM. That is another set of corresponding sides. So we got this ratio is equal. That is the answer of our question.
So we have done with the questions. If you want to cover more questions, check the link in the description. Now let's move to the next concept of BPT, the basic proportionality theorem.
Let's understand this concept. Let's have a triangle ABC and let's draw a line DE which is parallel to BC. DE can be anywhere, it can be on the upper side, lower side, on the mid part, anywhere, but it should be parallel to BC. Both of these line segments should be parallel to each other. If these line segments are parallel to each other, then the ratio of AD upon DB is equal to AE upon EC. So the ratio of these four line segments will be equal to each other. In the form of exact wording, the theorem: if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Here point D is dividing the side AB into two parts, AD and DB, and E is also dividing the side AC into two parts, AE and EC. So AD upon DB will be equal to AE upon EC if DE and BC are parallel to each other. This is the concept of BPT, basic proportionality theorem, BPT theorem. We are also having the converse of the theorem, that is, if these ratios, that is AD upon DB is equal to AE upon EC, then we can say DE and BC will be parallel to each other. This is the converse of the BPT.
Let's further deep dive into the concept through some questions. Here are the questions.
In figure 6.17, 1 and 2, DE is parallel to BC. Find EC in 1 and AD in 2. Here we are having two parts of this question. Let's take the first part. Firstly, let's observe the figure. In the figure, a triangle ABC is given, and in this triangle, the line segment DE is given as parallel to BC, that is the side of the triangle ABC. So DE and BC are parallel to each other. So we can apply the BPT theorem here. In the BPT theorem, if these two lines are parallel to each other, then the ratio AD upon DB will be equal to the ratio AE upon EC. So we got AD upon DB is equal to AE upon EC. In the figure, AD is given as 1.5 cm, DB is given as 3 cm, AE is given as 1 cm, and we have to find the missing dimension EC. We can simply put the value in the equation. We got 1.5 upon 3 is equal to 1 upon EC. On solving, we got the value of EC as 2 cm. We got the part 1. Let's take down the part 2. In the part 2, again a triangle ABC is given, and further the DE is given as parallel to BC. So DE and BC, these two line segments are parallel to each other. So again we can use the BPT theorem, but here AD is missing. We know DB as 7.2 cm, AB as 1.8 cm, and EC as 5.4 cm. AD is missing in this part. So we can apply the BPT theorem because DE and BC are parallel to each other. We got AD upon DB is equal to AE upon EC as per the BPT theorem. Let's put the given value. On solving, we got AD as 2.4 centimeter. The simple mathematical calculation. So we got our answer as 2.4 centimeter. So we have solved for part 1 and part 2. Okay. Before moving to the next question, let's again observe both the figures. And we will try to find the answer without touching the pen or the pencil. Firstly, let's observe the first figure. In the first figure, if you observe the line segment AB or the side AB, here AD is 1.5 and BD is twice of AD, that is 3 cm. 1.5 and twice of 1.5, it is 3 cm. So DB is twice of AD. As per the BPT, the ratio of left hand side will be equal to ratio of right hand side. That is the ratio of AB in which AB is divided will be equal to the ratio in which AC is divided. So on AC side also it will be double. Like AE is 1, then EC will be twice of 1, that is 2 cm. Got it? In the ratio term, on the left hand side the ratio is 1:2. So on the right hand side also the ratio will be 1/2. AE is 1 cm, so EC will be twice of AE, that is 2 cm. Got it? Similarly, let's apply the same concept on the figure 2. If you observe AC, the right hand side of the triangle, here 1.8 cm and 5.4 cm are given. Basically 5.4 cm is 3 times of 1.8 cm. Or in other words, we can also say 1.8 is 1/3 of 5.4 cm. Same philosophy we will apply on the left hand side because here BPT is applicable. So both sides the ratio will be equal. So here also AD will be 1/3 of DB, which is given as 7.2. So what is 1/3 of 7.2? It is 2.4 cm. So here the ratio is 1:3. The topmost portion is 1 and the bottom portion is 3 times of the topmost portion. Got it? So my point is that just by visually looking the question, looking the figure, you can mentally solve the question. Rest you can simply apply the simple mathematics on the paper. 90% you can solve in your mind. So this is the power of visualization. You should be able to observe the figure in very detail. So let's move to next question. In figure 6.20, DE is parallel to OQ and DF is parallel to OR. Show that EF and QR are parallel to each other. So let's observe the given figure. Here ED and QO is given as parallel and DF and OR are also given as parallel to each other. Firstly, let's take ED and QO. Again, we got two parallel line segment. Can you observe and identify the triangle around ED and QO? Yes, we got the triangle PQO. This is a triangle. We can apply the BPT as ED and QO are parallel to each other. We got PE upon EQ is equal to PD upon DO. Further, let's move to the next parallel line segment, that is DF and OR. So observe the triangle or identify the triangle around these two parallel lines. The triangle is POR. So we can apply the BPT theorem here. We got PD upon DO is equal to PF upon FR. Got it? The simple BPT theorem we have applied. The ratios will be equal. These two triangles are sharing the common side PO. So the ratio PD upon DO, that is the ratio of PO, will be common in both the equation or common in both the triangles. So we can equate both the triangles or both the equations. We got PE upon EQ is equal to PF upon FR. Got it? Further, let's dim all the unnecessary part. Here we got PE upon EQ is equal to PF upon FR. If you observe the triangle PQR, this big triangle, here can we apply the inverse of the BPT? That is, if these two ratios are equal, so EF and QR will be parallel to each other. We have simply applied the converse of the BPT in the triangle PQR. So we got EF is parallel to QR, which is the answer of this question. Got it? Simply, we have again used the same philosophy. We have identified the parallel line and around the parallel line, we have identified the triangle. We have done with this question. Let's move to the next question. In figure 6.21, A, B and C are points on OP. OQ and OR respectively, such that AB is parallel to PQ and AC is parallel to PR, show that BC is parallel to QR. Our first step, we will observe the question and also observe the given figure. In the given figure, we are having a triangle PQR. The three vertices are joined by the point O through PO, QO and RO. These three line segments are having the point A, B and C. And these 3 points A, B, C are also joining to form a triangle. So this is given in the question. Further, it is also given AB and PQ are parallel to each other and AC and PR are also parallel to each other. In the previous lecture and in the theory lecture, we have seen that our first step, we will identify the parallel lines in the BPT question. And the second step, we will try to visualize or identify the triangle around these parallel lines. Let's take our first parallel line as AB and PQ. Are you able to identify any triangle or observe any triangle around these two parallel lines? Yes, we have a triangle OPQ. This triangle is having the two parallel lines AB and PQ, so we can apply the BPT theorem in this triangle. Let's observe the second parallel line, which are AC and PR. Are you able to again observe any triangle around this parallel line? Yes, we have a triangle OPR. This triangle, which is having the parallel lines as AC and PR. So again, we can apply the BPT theorem in this triangle too. We got two triangles and we can apply the BPT in both the triangle. And one thing more, that is these two triangles are sharing the common side. The side OP is common in both the triangles, so its segment, that is OA and AP, will also be common in both the triangle. Basically, these two segments will be common in both the BPT equation. Let's see how we approach this question. Firstly, let's check the first triangle POQ. In this triangle, AB is parallel to PQ. Let's apply the BPT. We got OA upon AP is equal to OB upon BQ. Okay, the simple BPT we have applied. In the second triangle, where AC is parallel to PR, again, let's apply the BPT theorem. We got OC upon CR is equal to OA upon AP. Okay, the simple BPT theorem 6.1 we have applied. Let's compare both the equations. In both the equation, OA upon AP is common. So let's equate the rest two terms. We got OB upon BQ is equal to OC upon CR. Okay, by comparing we can say so. Further, are you able to observe the triangle OQR? We got OB and BQ is equal to OC and OR, which is the part of the BPT theorem. If you observe the triangle OQR, we can apply the converse of the BPT, which is if OB upon BQ is equal to OC upon CR, then BC and QR will be parallel to each other. We have simply applied the converse of the BPT theorem 6.2. So we got BC and QR are parallel to each other, which is the answer of this question. Got it? We have done with this question. Let's move to the next question. ABCD is a trapezium in which AB is parallel to DC and its diagonals intersect each other at the point O. Show that AO upon BO is equal to CO upon DO. Let's observe the question. In the question, a trapezium ABCD is given. So AB and DC are given as parallel to each other. So these two sides are parallel. Further, the question is also talking about the diagonals of this trapezium. Let's have the diagonal as AC and BD. These two diagonals are intersecting at the point O. And we have to show that AO upon BO is equal to CO upon DO. So this is AO, this is BO, and this is CO, and this is DO. We can directly start with the answer, but I will show you how to approach this question. What you should think in your mind and how to approach the question. Directly jumping to the formula, rearranging the term will not solve the purpose. Let's see what you should think while solving this problem. So here we have to show AO upon BO is equal to CO upon DO. Here can we rearrange this equation so that AO and OC comes on one side so that we can form the line segment AC, and BO and OD comes on one side so that we can form the line segment BD. We are doing so that our BPT theorem can be applied. BPT is basically applied on the sides of the triangle on which the single side is divided into two parts. So this is the complete side which is divided into these two parts, and in the BPT theorem or the BPT equation, these two parts are on the one side. So basically what we are doing, we are making AO and OC on the single side so that somehow we can make AC as the side of the triangle. We will identify the triangle and we will make AC as the side of that triangle so that BPT can be applied, and we can get the ratio as AO upon OC or OC upon AO, anything which is applicable. Similarly, we are making BD as the side of the triangle so that we can apply the BPT theorem as the side of the triangle. Got it? So here we got AC and BO as the side of the triangle. Can you identify any two triangles in which we are getting the side BD and the side AC? Firstly, let's talk about AC. For AC, we are getting these two triangles. Secondly, let's identify the triangle in which we are having the side as BD. So we are having this triangle in which we are getting the side as BD, and this triangle also we are getting the side as BD. So for side AC, these two triangles, for side BD, these two triangles. Further, can we identify any two triangles from the first side and from the second side in which we can get any common side? We are searching for the common side because once we apply the BPT theorem, we always look for the common side that get cancelled out or that help us in equating the two BPT equation. When we solve it, you will further understand it more. If we take this triangle and this triangle, we are having the side BC as common. We can also take this triangle and this triangle in which the side AD as common. You can take any of the two cases, it will help you to solve the question. We will take any of the one case. Let's take these two triangles. You can take any and you can solve that. Okay. We have taken this triangle because we are having AC. We have taken this triangle because it is having BD, and both the triangle are having common side as CB. Let's move further. We can only apply the BPT if the two line segments in the triangle are parallel, as we have seen in the previous cases. Here we have to draw a line segment EF, which is passing through the point O, and this EF is parallel with CD and AB. AB and CD both are parallel to each other. If we take a line segment EF which is parallel to AB, that line segment will get automatically parallel to the other side, that is CD. Okay, EF is parallel to AB, AB is parallel to CD, so EF will be parallel to CD also. So these three line segments are parallel to each other. Now we got the perfect triangles in which we can easily apply the BPT. Let's take the triangle ABC. Here in this triangle, the line segment OF and AB are parallel to each other. Okay, the complete line segment EF is parallel to AB. So OF will automatically be parallel to AB as OF is just a part of EF. Got it? Let's apply the BPT. We got CO upon AO is equal to CF upon FB. Similarly, let's apply the BPT in the triangle BDC, the second triangle. Here also OF and CD are parallel to each other. We can rotate this triangle for simplicity if you are not able to visually apply the BPT. So we got FB upon CF is equal to BO upon OD. Now we can compare both the equation because here the side CB is common in both the BPT equation or both the triangle. But on one side we are having CF upon FB, on other side we are having FB upon CF. Let's rearrange this equation so that we got CF upon FB. We can do the inverse. We got CF upon FB is equal to OD upon BO. Got it? We have simply done the inverse so that we can exactly match both the equations. Here these two terms are matching with each other, so we can say OD upon BO is equal to CO upon AO. we can rearrange the terms and we can rewrite it as AO upon BO is equal to CO upon OD, which is the answer of our question. Got it? This is the answer. I could have directly start with applying the formula and applying the simple concept, but you should understand that why we are doing so. How to identify the different triangle, two triangle in which we can find the common side so that while equating the two equations of BPT, it became very easy. So this is the trick or the approach that you should use, because in the exam the questions will not be direct. The question may be tricky, the question may be slightly different, but the basic concept will remain the same.
So we have done with the questions. If you want to cover more questions, check the link in the description. So that's it for this lecture. If you like the lecture, please like, share and subscribe to our YouTube channel. Thank you very much for being with CREATA Classes. Best of luck and have a great day.